Essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya L1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the Sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Annapurni Subramanian alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, SOOT is going to be looking at the ultraviolet radiation in 2000 to 4000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have. Thank you.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds, and how does it impact?
Thank you. Thank you for giving opportunity to come into this show. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that's the sun. Just I want to tell to the viewers that actually the sun, which is our hero, basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also this sun is plasma. Now when we are talking about the heliosphere, actually with this all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now, Dr. Bibin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues they mentioned actually the major transition events like coronal mass ejection. That's a huge mass which is coming out of sun. Basically it's a plasma. Basically when we are talking about solar wind, basically nothing but it's the extension of the corona. That's the atmosphere. Now these particles actually they only actually modulate the energy and momentum of the planetary atmospheres. See, we when the sun is quiet, like it is not aggressive, suddenly what we are getting the ambient solar wind. So if you look into that thing actually, that one actually gives what we call it about the interactions, what we call the normal routine phenomenon which is happening on there. But when there is sun is angry, it gives like in a CME, CAR or these sort of events are happening, that is really going to affect our planets. That's what we call the space weather. Now our intention is to understand first of all actually what these effects, basically the solar wind in the ambient condition as well as during this transition events, how this solar wind behaves, and also how this coronal mass ejections which is passing through different planets, how actually what are the different things like what we call about the microphysics, macrophysics and the mesophysics of that things that we want to understand. So one thing is actually it's a physics subject to understand because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually we can definitely monitor the parameters. Like what Papa will measure the electrons and ions, we will be getting energy, direction and angular information, mass information. So if we know these things related to electrons, electrons we don't want the mass, but for the ions we are getting the mass information. Coupling all this information, actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects.
Yes.
So in due course, actually, with the L1, in addition to other L5 missions, we will be able to tell. This is the importance of the plasma missions.
Yes.
That actually, as you mentioned actually, earlier with the lunar mission, we tried to understand that thing. Really, it changed this plasma studies, changed the perspective of the moon. Now, Aditya will give more detail.
Yes. Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. So, you manage the beautiful solar observatory at Nainital. How do you think the studies of heliophysics will supplement Aditya L1? Can you tell us something about the history of solar observatories in India?
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space, and this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program, and then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian 1 mission, the entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian 1 observatory class mission. And as you heard from my colleagues, that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage.